The first question they want you to know, they ask you why the UK doesn't have the units, coefficient of kinetic friction. This is the reason that I want to show you before I give you why. Remember this formula, you did it in grade 11. Fk equal to UK, coefficient of kinetic multiplied by the normal force. Now, if you take normal force to this side, both of these units are n and n, so they're going to cancel one another. That is the reason why UK doesn't have units. That's how you answer the question. That's why there's no units. This is how you can do it. Very easy. The second question that they're asking you is to draw a free body diagram. You will realize in most cases, most of these questions, they always ask free body diagram, free body diagram, free body diagram. Even in grade 11, you did that free body diagram. And I was telling my class that in metric, when you do work, energy, and power, you're still going to do these. Here it is, it's coming again. But I hope you still know how to draw the free body diagram. Let me show you how to draw this one, the one in the our question now. You have the dot, you have the Fn, you have the weight or the Fg, and then you have the applied force. Remember, the applied force in this case was in the form of angle. And then there was that frictional force. This is how to answer the question. But there's the other one I like beside this one. Let's say or. You can also have the Fn and the Fy. I'll tell you why, because I like this one even better than the first one. So the frictional force is still there. The applied force will be there. Now, what happened is, in the case of this one, it's easy to know that these two, Fn plus Fy, they are opposite to Fg, that is force of gravity. So it's better for you if you still remember this one than this one, because it's easy to solve this one than to solve in this one. But that was question number 2. We want to find WFK. But fortunately, the examiner was good for you. They gave you the FK. Yours is just to prove it. So this is what they want you to find. They want you to prove this FK. This is a very interesting question. I'm going to help you to solve it. But before I help you, let me show you something very interesting. Remember, on the formula sheet, you have W equal to F delta X cos theta. That's the first formula you have on the formula sheet under work, energy, and power. Then, I gave an example. I said, if you put applied, you put applied here, delta X cos theta. So now I want Fk, so I can easily say WFK equal to Fk delta X cos theta. That's the way you should write it. But remember Fk from grade 11 syllabus. Fk is coefficient of kinetic multiplied by the normal force. Now, which means on this Fk, I'm going to put UKN delta X cos theta. But there's something I want to show you now. From the free body diagram that I show you in number 1, I said to you, this is what you must do. If you have Fn, then the Fy is going up. They are in the same direction. And then you have Fg here. Now, what happened here is, Fn plus Fy equal to Fg. But what do I want here? I want Fn. Then I will say is Fg minus Fy. Remember, Fg is mg. Good. This is excellent. This is grade 11 work. But you need it now in metric. Now you substitute here. Then you say UK, instead of the Fn, now we put mg minus Fy, delta X cos theta. Now I can solve the problem. It's a very interesting question. Let's solve it. What is our UK? It's given as 0,2. What is our mg? 200. Multiply by 9,8. Minus Fy. Remember, the box was moving on horizontal. Let me quickly show you what is happening here. This was 20 degrees. It was going up. Then when you draw this line, you have Fy. So it's the vertical. So it's going to take sine. Then you have F sine 20 degrees. Why I'm putting F? Because it was not given. This is your F. This is your Fy. This is your Fx. This is very nice. It will also help you. Right. Now, but in this case, I've given delta x. So I'm going to say delta x is 3 and then cos 180 degrees. Remember, cos 180 degrees is in the opposite direction. So you mustn't forget that it's frictional force. Therefore, you work it out with your calculator. The F is still here. You mustn't forget because our answer that we have to show has got the F. Therefore, when you work out the whole thing with calculator, you will arrive to that answer, which is minus 1176 plus 2005 F. The F is still here. And then you put the unit J. Remember, no units, no mark in the marking. We don't give units if you don't give mark if there is no units. This is our question. Very interesting. What are they testing also? The grade 11 work, the FK. And also to show, because sometimes they ask you to solve, but in this case, they wanted you to show this answer. This is a very interesting question. Let's do number 4 now. What they want you to find in number 4 is they want you to find force. The force that was given in number 3. Remember, in number 3, you were given WFK is minus 1176 plus 0,205 F. So the F, that's the F you have to find out. So we need to find this F in number 4. But we need number 3. Even if number 3 you didn't get it right, but you can still use it in number 4. That is another advantage. Therefore, let's start to do the formula. W net equal to W applied plus W friction, which is that one, plus the WG plus the W normal. Fortunately, on the horizontal, those gravity and normal are 0. So let's substitute. The W applied will be F applied delta x cos theta plus this one we put minus 1176 plus 0,205 F. The two, this one are 0, 0. But there was something very interesting on the question. They say the net work done is 0. What does that mean? It means on the W net you put 0. Why? Remember, you want F, so you cannot have 2 unknown. You should have 1 unknown. So this was very interesting. Now, we must substitute our F applied. Our F applied was F cos 20 degrees. Why? On the diagram, let me quickly remind you again. On that diagram that you have, there was 20 degrees here. And this, remember, is your F. And then this is your Fy. But this, in this case, we want the Fx or F horizontal, which will be adjacent and hypotenuse. Then it will become F cos 20 degrees. You mustn't forget that. Now, this is for only applied. That means we still have delta x, which is 3. And then cos 0 degrees. Remember, cos 0 degrees is only on the direction of the motion. Applied can never be minus. It will always be positive. That's why I put cos 0 degrees. But can I explain something to you now here? Listen here. This applied force is not like, if this was like only that and you pull it like, let's say it was 50 Newton straight like that. On the F applied, we'll still put 50 Newton only. But because in this case, you are pulling it. So you are pulling it in the form of angle. That is the reason why this will be F cos 20 degrees. So you must be careful on that. It's not the same, these two. This one is straight. If it was this one pulling straight, to 50 degrees, 50 Newton straight. But because you are pulling in the angle, it's F cos 20 degrees. This is what you must remember when you write exam. I can remove it here. I wanted just to show you. Right. Now, then here you can just remove the brackets by having minus 1176 plus 0,205 F. And then, remember, the W net was 0. Now you have this F, and then you have this F. So you're going to add the two F. They are now the like terms. And then you press calculator for cos 20 for cos 0 degrees. You know how to use the calculator. You are in metric. Therefore, F equal to 388,88 Newton. This is the force that they need on number 4.